Activity 2. Modifying an existing f1inSchools car design. In this activity, you will modify an existing f1inSchools car using the sculpt command and T-splines. You will then be able to use this technique learned to very quickly create your own unique body and wing shapes by modifying the standard Autodesk Fusion 360 f1inSchools car model. Following Activity 2, you will be shown how to save parts in an STL format ready to CNC machine or 3D print, and how to generate an orthographic drawing of your 3D f1inSchools car assembly. Step 1. Open an assembly. Select the Data panel in the top left corner of the screen and open the Dataset folder and select Autodesk Fusion f1inSchools car. If you haven't already done so, you can upload your dataset here. Close the Data panel when the car is open. You should see a browser window on the left side of the screen. If this is not visible, select View and Browser. Here you will be able to see all the components that make up this assembly. You can stretch out this window and make it easier to read the component names. Look for the component entitled f1inSchools Hubcap. Click the yellow light bulb and you should see that one of the gray wheels inserts will disappear, and the light bulb will turn blue. This is handy to highlight certain parts of your model. Scroll to the bottom of this browser window. You will see a hidden component called F1 block. Let's make this visible. This is a copy of the F1 model block and demonstrates that the designed car body fits within the block. As in this example, it is essential that this check is done with the CO2 cylinder of the F1 model block and the designed car aligned coincident. This is important as if the designed car body is any bigger than the block, it cannot be machined. The block here has been shortened to 210 millimeters to further assist in checking fit. 210 millimeters is the maximum size that can be machined due to the clamps that hold the block in the CNC router, and it is also the maximum length that the car is allowed to be according to the f1inSchools regulations. You will notice that the rear wing is outside the model block. For our tutorial car, this is fine because our wings are going to be manufactured separately by a 3D printer and then later glued onto the car body. If you wanted your wings to be made from the F1 model block material, then you would also need to fit them within the dimensions of the model block. Right-click the component in the browser window and select Opacity Control. In the Opacity Control window that appears, slide the opacity to 40%. You will now be able to see how the car fits inside the body block. Click OK. Step 2. Design for manufacturer considerations. It is very important to have a basic understanding of how the car body will be manufactured in order to create a successful design. In industry, all products are designed with consideration given to any limitations that may exist due to the available or chosen manufacturing method. An f1inSchools car is no different. It is important to understand the manufacturing technology and process requirements so that the car designer can create a car body shape that is actually possible to manufacture by a CNC machining process. CNC, computer numerical control, machining is a very important and widely used manufacturing method in industry. This is why it is compulsory for f1inSchools teams to manufacture their car bodies using a CNC machine. Many schools are equipped with 3-axis CNC machines, which is the minimum requirement for car body manufacture. High-speed 3-axis CNC routers are ideal for making f1inSchools car bodies. Autodesk f1inSchools tutorials support manufacturing via a Denford 3-axis CNC router. The recommended standard CNC machining method is to machine car bodies using 2 machining operations, one operation for the left side of the car and one from the right side. For each operation, the F1 model block is mounted on its side in the CNC machine via clamping in the special f1inSchools machining fixture. This method provides a wide range of car profile designs to be machined with a minimum amount of machining operation. This picture illustrates this. The green arrows above indicate the 3-axis direction system of the CNC machine. These are three axes of direction the cutting tool moves in, often simultaneously, in order to remove the excess model block material revealing the profile of your F1inSchools racer. The standard method of manufacture is to machine the car body using two machining operations, one machining operation on each side of the car. The right side of the car is machined with the model block mounted as pictured above. The model block is then rotated 180 degrees about its x-axis to machine the left side of the car body. The left side machining operation is simply a mirror image of the right side. Due to there only being three axes of direction of movement that the cutting tool can move in, some shapes or profiles may not be possible to be machined. The diagram below helps explain this further. The model block, green, and car profile, blue, are shown oriented on their sides in the CNC machine. The darker blue circle in the middle is the CO2 canister hole in the model block. The cutting tool can remove all of the material produced in the design shown in blue, as it can be reached from the left and right sides of the car. The material shaded in red cannot be removed, as the tool cannot reach this area from the left or right side. As pictured, it is possible to mount the model block in the CNC router oriented to allow machining from the car body top. This can then also be inverted to allow machining of the car body bottom if required. These would be additional machining processes, increasing the complexity, time, and cost to machining the design. Note that with this design, there are still areas shown in red that the cutter cannot access. These areas are not possible to machine using any orientation. Finally, the size and shape of the cutting tool needs to be considered. The standard machining process for F1inSchools car bodies uses a 1/4 inch diameter ball nose shaped cutter. Looking at the diagram, you will notice that a small radius fillet of material in red remains where the two edges meet at an internal sharp corner. This is due to the ball nose shape of the cutter tip. This example is a similar body profile to the previous. However, here the slot down next to the left and right sides of the CO2 canister housing is not as wide. The slot is narrower than 1/4 inch, and therefore the cutter cannot access and remove the material in red. Any slot or groove feature like this that are narrower than the diameter of the cutter cannot be machined. Hopefully now you have a better understanding of the CNC machining process used to manufacture F1inSchools car bodies and the few limitations that this imposes. You should now keep these factors in mind as you unleash your creativity in designing your F1inSchools racer car bodies. Step 3. Editing the wings. From the data panel, open Autodesk F1 f1inSchools car. You will notice this is not an assembly. You will only be editing the body and the wings. Click the plus underneath the folder icon at the bottom to open the timeline. Click on the front wings and you will notice 3 lines appear over one of the sculpt icons in your timeline. Double-click this icon to open up the sculpt environment. You should notice the tools change. The rest of the components will now be grayed out. The wing is now the active component. You will notice the wing is made of line sections called T-splines. These are all editable. Click Modify, Edit Form. Click on the front left rectangle of the wing. You will notice that the opposite rectangle gets selected also. There is a line of symmetry in green through the center, so any changes made on one side are reflected on the other. The triad indicator allows you to pull and push parts of the sculpted design. Using the translation arrows, drag the sketch of the wing. Press undo to return to normal. This time, turn one of the rotation handles on the triad indicator. You will see the wings twist. Press undo. This time, try selecting an edge and do the same thing. Undo. Let's select a vertice. Notice the different effects? Make sure you click undo and go back to the original shape. The Edit Form window allows you to narrow down the selections. Let's select this left rectangle here. Hold down the Alt key and drag the left translation arrow about 3 millimeters. Holding Alt adds new geometry to the shape, so you can create complex shapes. Dragging without Alt just changes the original shape. Double-click this edge here. The entire edge should be selected. Pull the translation arrow forward approximately 4 millimeters. Note, Rule T8.6 states that the front wheels may only be obstructed to a height of 15 millimeters from the track surface. Because of this, you need to alter the positioning of the entire wing. Select Modify, Edit Form. Double-click one of the faces to select the entire wing. Let's view for the car from the side. Using the top translate arrow, let's move the whole wing down approximately 7.5 millimeters. Now use the top rotate triad handle and turn it counterclockwise approximately 5 degrees. This will straighten it out a little. Click OK and Finish Form. Using the same process, enter the sculpt environment for the rear wing. Select Symmetry, Mirror Internal. Select the face shown. Use the view cube to rotate the model and select the corresponding side underneath the wing. And click OK. Use the view cube to rotate back to the top view. Select Modify and Subdivide. And select the face of the wing you selected previously. Click OK. Splitting T-splines into smaller sections gives you more control over minor adjustments. Rotate the wing and subdivide the back parts as shown. Click OK. Select Edit Form and double-click the new edge you've just created. Drag the translation arrow towards the front of the car approximately 5 millimeters and click OK. Select Edit Form again and select the two large end faces. Hold down Command-Control to select multiple items. Push these faces down approximately 0.8 millimeters. Click OK, then Finish Form. Note, if you've received an error message, you have pushed the edges too much and they have crossed over. Look at the T-spline lines whenever you edit the sculpt environment. They cannot cross over. Save your work. You will now edit the body of the car. Step 4. Editing the form and splitting the body. The body of the car is produced in a slightly different way. It is sculpted using T-splines and then the body is split. Click the body and look at the selected part in the timeline. Double-click the sculpt icon located before the split icon, which is automatically selected. Again, the body has a line of symmetry through the middle. Double-click the left-hand edge to select it. Go to Modify, Edit Form, and click the translation triad to stretch it downwards. Type a distance of -10. Modify the same edge again. This time, press and hold Alt on the keyboard while pulling the edges approximately 20 millimeters down. Click OK. Now modify the two edge T-splines shown. Click, hold Shift, click again. Click the triad as shown and type in -25. To push the front of the car nose inward, press OK. Next, subdivide the three faces near the back of the car. and click OK. Select the new line you've created by double-clicking. Select Edit Form. Let's move this in 10 millimeters. Rotate the model to check that it doesn't get too close to the canister hole at the back. According to the rules, you need to ensure that there is a minimum of 3.5 millimeters of model block material surrounding the canister hole. Click OK. With the same edges selected, edit form one final time. Use the rotation triad to twist the edge 70 degrees down. Click OK and finish form. Save your work. Your design will update and split the block into the shapes shown. Now you will use the tools in the model environment to add fillets to your car. Click Modify, Fillet. Select, holding Shift, the vertical axes near the wheel spaces. Type in a fillet radius of 3 millimeters. This is to allow for the rounded CNC router cutting tool that cannot create sharp internal corners when cutting your car. Click OK. Select the front of the car and put a fillet of 7 millimeters. Click OK. Select Fillet one last time. Let's apply a 5 millimeter fillet to the edges as shown. Make sure to select both sides. Click OK, and now let's save your work.